Right, for many years, if you have too many branch offices, more than one branch office, then what we do is we always route the traffic via the central office. You got various branch office. So what you have is a central office or a data center. All the branch office used to come to the central office, the data center, and from there, wherever they want to go, they can go. If someone wants to go from one branch office to another branch office, they need to come to the head office, the data center. And from there, they get routed to another branch office. So we used to use WAN connection. We used to have a dedicated WAN connection using layer 3 or layer 2 MPLS circuit to connect to the data center. But if you're talking to another branch office, then okay, what if I want to talk to an internet? What if my application is in Azure cloud? Then what I need to do is I need to come to the data center first, and then I need to be routed to the public cloud. And then response again comes to the data center, back to the branch office. This is slow. See this picture. This picture explains what we just spoke. We are trying to understand why SD-WAN. The remote site, the branch office, in order to go to another branch office, it comes to data center. Not only that, if it wants to go to the cloud service, like Office 365, VirtualBox, you know. So all the enterprises applications which are there in the cloud, it cannot access directly. It has to go always through the data center. So it uses the internet, but not the actual internet. It uses the WAN, go to the data center. There is no other option. The traffic cannot leak out because there is a tunnel in between these two edge nodes. So the traffic goes from this end to that end, which is another site, happens to be a head office, and from there it gets rerouted to the internet cloud. Now, not only few services, now most of the services have become cloud service. So this WAN design that we spoke about, the traditional design, they no longer work well because everything is application now. So business needs some change in the approach so that we can satisfy this SaaS, which is again a cloud service, IaaS, which is another cloud service. And then a lot of resources are in the cloud for enterprises like Office 365, Internet, and many applications are hosted even in the cloud, not only in the data center, or some applications are hosted in the third-party data center or another data center. So the traditional WAN connectivity that goes between the branches is not more effective way of connecting the application which is in the cloud. It increases the cost because you need to go to the head office and then from the head office reroute to the internet and then come back to the head office and then from head office to the branch. So this increases the cost because you're going to utilize the bandwidth more than what it's supposed to be. Secondly, latency. As the traffic goes to the data center and then moves to the cloud, this increases the round trip time. So latency increases. Availability. If the head office, if the data center fails to route, or if the data center goes down, then no branch office can have the access to the cloud service nor to the data center. Next is the velocity. Configuring this MPLS private circuit is not that easy. Once it is established, fine, but if you want to add a new site, it needs a lot of approval, a lot of agreement with ISPs, and it takes time. It's not that easy to spin around. So the time taken, the velocity is also increased. So we need a solution. We need a public cloud which will act as a data center. Instead of our remote office as a data center, we need to adapt the public cloud and make the public cloud itself, where a lot of applications are natively present, to be our data center. Or in another word, we want the cloud itself to be the control and management plane. So then it will be easy for us to go to the branch office as well as the internet as well as the cloud application, because the controller is there in the cloud itself, not in the head office. That can reduce the time, velocity, cost, etc. So we need to have a low price solution. At the same time, we need to have a fast converging, high available solution. Software defined wide area network is the solution, is the current solution that we have for this problem. You see, when we have SDWAN, you see the remote sites, if they want to go to internet, they no need to go to data center. They can go straight to the internet. They can go and straight use the cloud applications, right? And if they want to go to talk to the remote data center, then they can use this tunnel. So here also you're going to have tunnels, but these tunnels are not controlled by the data center. Instead, you see there is a controller in the cloud itself. So software-defined WAN can form channel between the data centers. Also, it will give you flexibility of going to internet straight without going through the data center. So SD-WAN is a new centralized approach to the network management that abstracts the underlying network infrastructure away from the service and applications that runs on the network. So we are no more dependent on the private VPN tunnels because we are going to have a centralized management, and the centralized management can be in one of the branch office, can be in the cloud, but data plane is not always through the centralized office. Data plane is decentralized. That is what, this should not contradict. See, new centralized approach, decentralized network. We should not get confused here. There's no real confusion here. If you see here it says we have a centralized approach, which means you don't need to go through the data center always to go to the branch office or to go to the internet. Meaning you abstract, that's a nice word, abstract the underlying network infrastructure away from the service and application. The service and applications are going to have an overlay path. That overlay path is built with irrespective of the underlay. In the early traditional method, underlay makes the difference. The VPNs, the MPLS layer 2, layer 3 VPNs makes the provides the path. Whereas the software-defined WAN is an overlay concept which abstracts the overlay from the underlay. The management of the overlay is not in the head office, but it is centralized. To understand this better, let's talk about the olden days computer. Olden days personal computers. What we used to do is, if you want to use a Bluetooth via headset, in first place there was no Bluetooth headset in the olden days. Let's say you want to connect a wireless card to your computer. What we used to do is we open that that CPU, the box. In our personal computer, we used to open the box. We used to install the PCIe or PCI NIC card or wireless card. Is that okay for you? Will that work immediately? No. You need to install a driver. They used to sell it with a driver. And we used to put the CD inside the CD tray, install the driver. After you install the driver, only then the card, the wireless card that you install will work over the motherboard, will get attached to the motherboard. Only after that you can use the wireless card. See, it was totally different from what you have today. Today, if you buy a Bluetooth headset, you just connect it. That's all. All the drivers are already inside. It recognizes. You buy a new adapter card, install it. Your operating system already knows it. It's plug and play. It is plug and play. We need something like that in network. We do not want every time uh, a team of people or more than one team coming and planning and executing, deploying. We don't want that. Actually, I want it. Industry don't want it because they want to reduce the cost. They don't want too many employees. So they don't want it. They don't like it. They want to reduce the cost. They want to spin it very fast. When they add a new remote site, zero touch. The new site should come boom like that. They don't want an engineer or a group of engineers coming down and spending months together deploying. Uh, they don't want that. They want a plug and play network. This is what SDWAN promises. So today, if you just add the cards and it becomes one system and it starts working. Likewise, SD-WAN. Likewise, SD-WAN provides a single stop approach. Like you don't need to configure router and then a switch and then a firewall and then a wireless controller. SD-WAN has got all in one. Which is reducing the cost, time of deployment, also the jobs of people. You cannot deny that. You see, even for wireless, we have SD-WAN called Meraki. We are not going to deal with Meraki, but what I'm saying is that's the SD-WAN. Instead of configuring individually routers, firewalls, switches, bridges, concentrators, wireless access point, comes all in one was one system. You need to just plug and play. So the reasons they give is this. The reasons they give is humans are making error. So what? Because humans are making error, you will replace with robot. And where will the food come from for the human then? It's a part of life. Error is part of life. Risk of human error. They don't want error in the network. If human being does a deployment, configuration errors are common. So they want machines to do that. They want automation. So they don't want per device configuration method anymore. They don't want manual configuration per device anymore. Next, service veracity. As I said, you can spin it out. New data set can emerge in no time. But the traditional networks are slow because you need to go to the devices one by one, configure the CLI. So in a large scale environment, it is difficult. But SD-WAN can parallelly push the necessary configuration to many devices and bring the site up. Analytic. In traditional network where devices are managed in a decentralized manner, No one of us know the big picture, meaning we do not know the end-to-end topology. We have limited visibility to our topology. Maybe you have a very good visibility to your network, but we don't have visibility to our ISP network. So when I want to talk, when I have communication between my head office and branch office via the ISP, I don't have the big picture. So to understand the big picture, different teams need to get involved, like ISPs. People from ISP need to sit together with the customer, and they used to do the maximum what they can do to understand end to end, based on which the policies, QoS can be written, which was a very difficult task. These are all the difficulties. But the benefits of SD-WAN is you got a single management plane. Like today's computer. One single operating system is enough for any add-on line cards. All drivers built in it for management. We call it a single management plane, meaning what does it mean? It means that you have a management plane which is in one place, not like you go from here to the center office and then center office move the packet to internet and internet moves back to center. Not too many places the decisions were made. Decisions are made in one place, and accordingly the data plane creates the overlay tunnels. So one of the main idea of SD-WAN is to administrate the wide area network through a single centralized management plane. The system itself to manage the underlying network devices. This will provide many benefits, business opportunities, and better overall experience. Let's see this picture. As I said earlier, you see, um, all that we need to do is just go and configure that centralized management plane. You don't need to configure the individual components. These individual components get configured. See, user simply signify intend to use the system. That's all. He wants to use the system, the network. And the configuration, it configures all the underlying components, all the networking devices that get configured according to the intent of the user. So you speak to the system. Earlier, the approach was opposite. We used to speak to the components, and then components makes the system here in a traditional method. In the traditional method, the system comes up later. We first talk to the components, but now it's the opposite. You speak to the component, you speak to the system, and the system will speak to the components with necessary configuration. Meaning, in another word, what they're trying to say is automation, isn't it? Automation. Yeah, so automation is what they're trying to say. A centralized manner, you just put the configuration and move the configuration to the respective devices. And this also reduces cost. And we can also leverage all transport services such as broadband, 4G, 5G, MPLS, and all other IoT devices, IoT services. You know, earlier for IP we need to do separate configuration. For MPLS we need to do separate configuration. 4G, 5G separate configuration. Now, not necessary. You just take those connections and include that in SD-WAN. SD-WAN will design automatically the necessary configurations. And not only that, it can use the SD-WAN can use combinations of different transport services in a secured manner. Means you can have an IPsec tunnel over these services, transport services. Improved uptime. Because it eliminates the human error, there is no troubleshooting. You see, earlier we had a paper called troubleshooting, isn't it? CCNP teaching. Now we don't have. Why? We are slowly moving into the automation. So troubleshooting is only, you need to just check the reachability between the management tools like vManage, vCenter, vManage, vSmart, vBomb, etc. This is more secure. You don't need to secure each device. Security is also centralized. So end-to-end security is applied. It is not box by box. Box by box is very hard. You need to go to each box and enabling security policy. It is very difficult. But this is end-to-end centralized. Better analytics. So in a large-scale network, you don't need too many people, very less people, but more visibility. As a result, you can deploy very quickly the network as per your policy, as per your requirement. When you add a new site, in very less time, with few people, or even no people, nobody, which is zero touch deployment. Just someone adds the edge device, that's all. Someone need to be there in the remote office to power on the edge device and connect to the service provider. That's all. All the rest will be taken care by the centralized manager. So, better analytics is another advantage of customer. Forwarding based on actionable information, meaning real-time information. In a traditional manner, we need to do some examining about the link state, bandwidth, blah blah. And then we used to say this is the best path for the packet to go. You remember in segment routing, in NPLS, traffic engineering, we used to write the commands to move the packet via a path, and if that path has got less bandwidth, then we used to shift it to another path. We called it as traffic engineering. But if you compare to SD-WAN, we won't agree those RSVP traffic engineering as a traffic engineering. Why? There is a lot of human intervention needed. It is not machine learning. Here it is machine learning, ML. That's the matter here. There it is human. There it is human. We go hop by hop, analyze the traffic, analyze the path, and then we decide the path. And we decide if something goes wrong, where to fail over. We do everything manually. But that is like, in olden days when we don't have Google Map, we take a physical map and we position ourselves in the map, and if we want to go to airport, we see there are two different ways to go to airport, and we pick one best path based on the physical map, and we keep going. And if there is any traffic jam in the path, then we take a diversion. Yeah. So that is like a traditional network based on the bandwidth and link status. But when you have Google Maps, you have end-to-end visibility. You very clearly know that this path will take 5 minutes late, delay than the other path. Even the time it calculates and tells you, because the Google Map using the satellite as a as a as a reference, Google Map can show you how busy is the road, how long it will take for a car to move from this end to that end, and what are all the different ways you have, and which way has got a uh, better uh, the bandwidth means the road, free road, which road is going to take less time. All those calculations are automatically done by Google Maps, based on which you move your car, you drive your car. Right. The paths are determined. So you have many paths. You have internet, you have MPLS, you have 5G, 4G, you have broadband, you have many options. Now, which one is best for end to end? That can be provided by SD-WAN, because SD-WAN has got more visibility. All right. So this is more good because you know where the traffic jam is. You know before you start from your original place, starting point, you clearly know where the traffic jam is, which route will take me faster, and more. So using SD-WAN is like you have a GPS, global positioning system, which helps the driver to avoid travel delay. SD-WAN also helps the packet to go faster to the destination by avoiding the path with jitter, packet loss, latency, etc. So SD-WAN is a solution for less cost, high velocity, all those benefits we just saw. Yeah? So there are two SD-WAN solutions that Cisco has given. One is Meraki, the other one is Vectela. Both are SD-WAN, but both are not designed for same environment. SD-WAN is for wireless environment. Vectela is for enterprises with various branches, for large-scale enterprises. Right? But both are SD-WAN. Meraki is much easier to understand than Vectela, but the purpose is different. Right? So our focus is to sorry, let me disconnect the audio and one more. So here it is very clearly written like Cisco Vectela is enterprises level SD-WAN solution supporting complex WAN technology with high degree of customization. Meraki is also an SD-WAN solution with basic level of customization designed for small and medium-sized organizations. As I said earlier, it is also coming along with wireless support. Meraki for small network, Meraki for wireless network. Meraki itself is again, two categorized as two separate feature. Meraki with wireless support, without wireless support. Okay. Anyway, Meraki is not our aim. Our aim is to focus on Cisco with Taylor SD-WAN. So what is SD-WAN? Hold on, let me bring this up. As I already said earlier, we didn't have much application in the cloud, but today most of the applications are in cloud, like Microsoft Azure, AWS, Amazon Web Service. So moving the user traffic from branches to the enterprises and then out to the cloud is difficult, expensive, not scalable. For rapid transformation, for rapid digital transformation of enterprises, we need to have a new approach, a cloud-based approach, which is what called as SD-WAN, software-defined wireless network. All right. This picture helps us very clearly what SD-WAN is. Wow, it's a nice picture. Look at this. Any location. You can have SD-WAN on campus, data center, industry, Soho environment, cloud, and transport can be anything. I'm going from down to top. Transport, you can have all of this or any of this or some of this, internet, MPLS, 4G, 5G, satellite, and the services that you want to have a normal routing service between the branch office or any analytical service or any cloud-based IaaS service or segmentation of network or security over the network. All these are services that can be deployed using the SD-WAN controllers. And this SD-WAN controllers can be on premises, can also be in cloud, and it may also have for multiple tenants. Right? Let's move on. So this explains the same thing which was shown in the above picture, but let's go through this one by one. Cisco WebTela SD-WAN solution provides the following improvements over the traditional WAN design. Connecting any location in a fast and secure and high available manner using ZTP, zero touch provisioning. Second, transport independent. You may have MPLS, 4G, 5G, satellite, the internet, never mind, SD-WAN can work. Next, abstract the underlying wide area infrastructure away from the service. Yes, because your MPLS, your IP route, everything is going to be an underlay, whereas SD-WAN is an overlay tunnel. You can have very effective topology, which is no way connected to the physical. Those physical topology limitations are no more. We can have multiple tenants on the same underlay, but the overlay is different for each tenant, etc. We can also have end-to-end security. As I said earlier, you can have IPsec over the tunnel. And also to manage, you have a single pane of glass to analyze the entire SD-WAN network. You also can provide southbound REST API that enables enterprises to create their own unique services and meet their desired requirement. I don't know why they use this tough word, the key requirement. It's nothing but needed requirement. Required uh, needed requirements, wanted requirements, any service that you want, customized service towards the down means towards the access layer. You can use a REST APIs. So the components of SD-WAN, we already know there's a management plane, there's a control plane, there is a data plane. Now, we also got additionally orchestration plane, management plane, control plane. 4 planes. Every plane has got their own responsibilities. For example, the data plane will never be taken care by the control plane and management plane. Data plane is to move the packet. It cannot be replaced by control plane or the management plane. Right? So here, compare this with traditional WAN design where each device participates in data plane. Yeah. Every device participates in control plane. Every device participates in the management plane. So you need to go to every device and configure, which is management plane. Based on the configuration, the routes are being determined in the routing table, which is a control plane. Based on that control plane, every device have got a forwarding database, which is the data plane. So this in the traditional WAN, the control plane, data plane, and management plane are not centralized. They are hop by hop, device by device. Whereas in SD-WAN, it is one component, centralized component. So you got one management plane, one control plane, and more data planes. All the edge devices are data planes. For branch office, I have one data plane. For campus, for DC, another one. For for the cloud, another one. And to do the orchestration, we have orchestration plane called vBond. So we have a vManage, a dedicated management plane. vSmart, a dedicated control plane. vEdge, which is a data plane. And then we got vBond, which is an orchestration plane. All right, so a single plane of glass where you can do analytical work for all. 4 planes: management plane, orchestration plane, control plane, and data. All right, we have seen these things earlier on all these planes. I'll explain you one more time in our next class, followed by a nice protocol called OMP, Overlay Management Protocol. And then we will talk about the different protocols like TLS and DTLS, which is used to communicate. We'll talk about key locks and so on in our next class.